We're looking at a few of the definitions that you meet in this networks topic. This first example asks us to find the number of edges. Edges are the connectors that join vertices. So you count up the number of edges here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this loop counts as one in itself. So that's 11 edges. The vertices are the points of the network: 1, 2, 3, 4, 5, 6, 7 vertices. The faces are areas which are bound by edges. So we've got 1, 2, 3, 4. Inside the loop is 5, and you also must count the area outside the network as a space as well. That would make a total of 6. The degree of a vertex is the number of edges which lead to it. So for the degree of vertex A, we've got 3 leading in there, that's degree 3, and of number of vertex B, there's 1, 2, and this loop actually counts as 2 edges leading in, so that's 1, 2, 3, 4. Over the page, and we have to classify some different networks. First thing was we have to look at each 3 and say, are they planar or non-planar? Now, a planar network is one which can be drawn without edges crossing over. Let's have a look at this one here. You can see that there are no edges crossing over, so that's a planar network. This one here, no edges which cross over each other, that is also planar. I've left this one to last though because it is a bit tricky. When you look at it, you can see that these 2 edges cross over, so you might be tempted to say this is a non-planar network. But thinking about it, can you imagine this edge here? If I was to get it and I could stretch it around, pull it over this way so the whole edge came back here, it's still joining the same 2 vertices, and I wonder if I can rub it out with liquid paper. So it's no longer there, we've moved it around the outside. It's the same network. The same vertices are joined by edges, only we've moved that edge and redrawn it. Now, a network is planar if it can be drawn without edges crossing over. Initially this one had edges crossing over, but because it can be drawn like this, it is a planar network. The next thing we're asked to comment about is if they're simple or non-simple. Now, a simple network is one which has no loops, and also every pair of vertices must be connected by at most one edge. So let's have a look at this one here. I can't see any pairs of vertices connected by more than one edge. There's no loops, so this is simple. This one's got no loops, but can you see this pair of vertices here has got 2 edges which are joining it. So this one is non-simple. Back to this one, and there is no edges there that have got pairs of adjoining edges, and there are no loops. This must be a simple network. Connected or disconnected? A network is connected if there is an edge or if between any 2 vertices you can find a path via means of edges. So from any point here you can get to any other point via means of the edges. This is a connected network. Whereas this one here, you cannot get from either here or here onto the main part of the network, so this is disconnected or not connected. This one here, from any vertex you can get to any other vertex. It's a connected network. Now the next one is directed or undirected. Now directed network just means that it's got some one-way arrows on it. And I think you can see this one here is rigged up in that way. So that's directed. No such arrows on these ones. These are undirected. And the last thing is a network is weighted if there are some little numbers on here which might indicate things like distance, time, things like that. This is a weighted network. These are unweighted.